Asphyxiation is the leading cause of death in confined spaces. That is why testing the entire confined space atmosphere before entering is absolutely necessary. Atmospheric testing of the confined space must be performed by a trained and qualified individual using a direct reading instrument that has been properly calibrated. This must be accomplished from outside the confined space unless permit procedures are used in tandem with air-supplied respirators for unknown atmospheres. Testing must be conducted to determine the following: oxygen level, the level of flammable or combustible gases and vapors, and toxic gases and vapors concentration. As we shared previously, the most common toxic gases are hydrogen sulfide and carbon monoxide. Knowledge of the prior and current chemical contents of the confined space, outside potential hazards and other influences will help to determine the type of toxic gas testing necessary to safely enter the space. Outside potential hazards may include the release of toxic chemicals or emissions from adjacent processes, such as exhaust fumes from a parked vehicle or welding fumes. The atmospheric testing or monitoring should be performed as often as necessary during the entry operation to ensure that safe conditions are maintained. However, for a confined space where isolation of the space is infeasible because of the size of the space, or it is part of a continuous system such as a sewer, atmospheric monitoring should be continuous. Testing enables employers to both devise and implement adequate control measures for the protection of authorized entrants, and to determine if acceptable entry conditions are present immediately prior to and during entry. When atmospheric sampling is performed, the entire contents of the confined space must be tested. Vertically sampling up and down throughout the confined space is especially important, as different toxic chemicals have different vapor densities. The vapor density of a substance determines whether it is heavier than air and settles in low areas, or lighter than air and rises to the top of the space. To understand this, you need to know that the vapor density of air has a value of 1. Any substance that has a vapor density greater than 1 will sink. Hydrogen sulfide has a vapor density greater than 1. It will settle into the lower areas of the space, so you should expect to detect hydrogen sulfide at the bottom when sampling the atmosphere. Methane has a vapor density less than 1. Therefore, it is lighter than air and will tend to rise or move to the upper areas of confined spaces. While sampling, always be sure to move slowly to coordinate the movement of the sample probe with the response time of the instrument before going to the next sampling level. The suggested practice is for samples to be taken every 3 to 4 feet vertically. If a hazardous atmosphere is detected during entry, each person must leave the space immediately. The confined space must be evaluated to determine how the hazardous atmosphere developed and to identify measures that must be implemented to protect employees from the hazardous atmosphere before any other entries take place.